Welcome, catch my point on physics. Today our topic is
Optics is the branch of physics that studies the behavior and properties of light, including its interaction with matter and the construction of instruments that are used to detect it. Optics usually describes the behavior of visible, ultraviolet, and infrared rays. Because light is an electromagnetic wave, other forms of electromagnetic radiations such as X-rays, microwaves, and radio waves exhibit similar properties. Most optical phenomena that can be accounted for using the classical electromagnetic description of light. Complete electromagnetic description of light are, however, often difficult to apply in practice. Practical optics usually done using simplified models. The most common of these, geometric physics, treats light as a collection of rays that travels in straight lines and bend when they passes through or reflect from surfaces. Physical optics is a more comprehensive model of light which includes wave effects such as diffraction and interferences that cannot be accounted for in geometric optics. Historically, the ray-based model of light was developed first, followed by the wave model of light. Progress in electromagnetic theory in the 19th century led to the discovery that light waves were in fact electromagnetic radiation. Some phenomena depends on the fact that light has both wave-like and particle-like properties. Expansion of these effects requires quantum mechanics. When consider light's particle-like property, the light is modeled as a collection of particles called photon. Quantum optics deals with the application of quantum mechanics to optical systems. Optical science is relevant to and study in many related disciplines including astronomy, various engineering fields, photography, and medicines. Practical application of optics are found in variety of technologies and everyday objects, including mirrors, lenses, telescope, microscopes, lasers, and fiber optics. Classical optics is divided into two main branches: geometrical optics and physical optics. In geometrical optics, light is considered to travel in straight lines, while in physical optics, light is considered as an electromagnetic wave. Geometrical optics can be viewed as an approximation of physical optics that applies when the wavelength of the light used is much smaller size of the optical instruments in the system being modeled. Geometrical optics. Geometrical optics or ray optics describes the propagation of light in terms of rays, which travels in a straight line and whose paths are governed by the laws of reflection and refraction at interfaces between different media. These laws were discovered empirically as far back as 984 AD and have been used in the design of optical components and instruments from then until the present day. They can be summarized as follows. When a ray of light hits the boundary between two transparent materials, it is divided into reflected and refracted ray. The approximations has been taken for the geometric optics. Geometric optics is often simplified by making the paraxial approximation or small angle approximation in the mathematical behavior that becomes linear, allowing optical components and the system to be described by the simple matrices. This leads to the technique of Gaussian optics and paraxial ray tracing, which are used to find basic properties of optical systems such as approximate image and object position and magnification. Reflection can be divided into two types: specular reflection and diffuse reflection. Specular reflection describes the gross surface such as mirrors which reflects light in simple, predictable way. This allows the production of reflected images that can be associated with an actual or extrapolated location in space. Actual means real, extrapolated means virtual. Diffuse reflection describes non-glossy materials such as paper or rock. The reflection from these surfaces can only be described statistically, with the exact distribution of the reflected light depends on microscopic structure of the material. In specular reflection, the direction of the reflected ray is determined by the angle of incident ray makes with the surface normal, a line perpendicular to the surface at the point where the ray hits. The incident ray and the reflected ray and the normal lies in single plane. Introduction to light. Light is a form of energy due to which we are able to see the objects which emits light. For example, objects like sun, lamp, candle emits light of their own, and thus they are known as luminous objects. There are objects like table, chair, etc. which are not luminous objects, and still we are able to see them, and this happens because they reflect the light which falls on them from a luminous objects like sun, lamp, etc. And when this reflected light reaches our eyes, we are able to see such non-luminous objects. Light rays basically consist of an electromagnetic waves which do not require any medium like solid, liquid or gas for their propagation. Wavelengths of visible light is very small and is of the order of 4 into 10 to the power of minus 7 meter to 8 into 10 to the power of minus 7 meters. Speed of light waves depends on the medium through which they pass, as speed of light in air is slightly less than the speed of light in vacuum. In the same way, speed of light in water and glass is much less than that in air. When light falls on the surface of an object, it can be either absorbed, transmitted or reflected. Absorbed. If an object absorbs all the light falling on it, then it will appear perfectly black. For example, a blackboard. Transmitted. An object is said to be transmit light if it allows light pass through itself, and such objects are transparent. Reflection. If an object sends back light rays falling on its surface, then it is said to have reflected the light. The process of sending back light rays which falls on the surface of an object is called reflection of light. Silver metal is one of the best reflectors of light. Mirrors we use on our dressing table in our home are plane mirrors. The angle of incidence is equal to the angle of reflection, and the incident ray, the reflected ray and the normal to the mirror at a point of incidence all lies in the same plane. These laws of reflection are applicable to all types of reflecting surfaces, including spherical surfaces. Real and virtual image. An image is formed when the light rays coming from an object meet at a point after reflection from a mirror. Real images. Real images are formed when the rays of light that comes from an object meets at a point after the reflection from a mirror. Real images can be formed on a screen and can be seen with the eyes. Virtual images. Virtual images is an image in which the outgoing rays from an object do not meet at a point. It will appear to meet at a point in or behind the optical device, but they do not actually meet after the reflection from a mirror. A plane mirror always forms virtual images. Characteristics of image formed in a plane mirror. Images formed by mirrors are always virtual and erect. Size of the image is always equal to the size of the object, and the image is laterally inverted. The images formed by the plane mirror are as far behind the mirror as the object in front of the mirror. Lateral inversion. If an object is placed in front of the mirror, then the right side of the object appears to be the left side, and the left side of the object appears to be the right side of the image. This change of sides of an object and its mirror image is called lateral inversion. Plane mirror. A plane mirror is a mirror with a flat reflecting surface. For light rays strikes a plane mirror, the angle of reflection is equal to angle of incidence. The angle of incidence is the angle between the incident ray and the surface normal. Therefore, the angle of reflection is the angle between the reflected ray and the normal. And a collimated beam of light does not spread out after reflected from a plane mirror except for diffraction effects. A plane mirror makes an image of an object in front of the mirror. These images appears to be behind the plane in which the mirror lies. A straight line drawn from part of an object to the corresponding part of its image takes the right angle with the and is bisects by the surface of the plane mirror. The image formed by the plane mirror is always virtual, means that the light rays do not actually come from the image. Upright and of the same shape and size of the object it is reflecting. A virtual image is a copy of an object formed at the location from which the light rays appears to come. However, the image is laterally inverted of the object. If a person reflected in a plane mirror, the image of his right hand appeared to be the left hand. Plane mirrors are the only type of mirror for which a real object always produces an image that is virtual, erect, and the same size as the object. Virtual objects produce real images. However, the focal length of the plane mirror is infinity. Its optical power is 0. In this session, we are going to see a sum related to plane mirror. From this, we are going to see how many images are produced if we place two plane mirrors parallel to each other. The distance between these two plane mirrors is 3 cm, and I am going to place an object exactly at here, and that is 1 cm from the second mirror and 2 cm from the first mirror. So this pink line mention the images produced by using the first mirror. So according to this diagram, the image produced by this object in the first mirror it will be 2 cm from the first mirror. That means from here to here it will be the 2 cm. We already know that the object distance is equal to the image distance produced in a plane mirror. And this will be the image of this first mirror and object for the second mirror, that exactly produced like this. And there is another image produced exactly 5 cm from the second mirror. That means the first image is the object for the second mirror, and there is the distance between the second mirror to the object is 1 plus 2 plus 2 is 5. So we are getting another image here as 5 cm exactly here. This image will be the object for the next image produced by the first mirror, and the distance between this object and the mirror is 5 plus 3 8. So we are getting an image exactly 8 cm from the first mirror. Similarly, for the second mirror, this will be the first image. That means we are getting the distance between the object and the second mirror is 1 cm. So we are getting an image exactly at 1 cm from the second mirror. This 1 cm image is the object for the first mirror, and we are getting a 4 cm object. That means 2 plus 1 plus 1. So the distance between this first mirror and this image is 4 cm, and this image will act as object for the next image is going to produce in the first mirror. So that is why we are getting an image here as 4. And this image will act as the object for the second mirror, and the distance between this image and the second mirror is 4 plus 3, that is 2 plus 1 is 7. So we are getting an image at exactly 7 cm from the second mirror, and this 7 cm image from the second mirror is act as object for the next image produced in the first mirror, so that the distance between the object and the mirror will be 7 plus 1 plus 2, it's 10. So we are getting the next image for this first mirror as 10 cm. So this is how the image formation in a parallel mirror Most commonly we are seeing this type of mirror images in a barber shop, in a trial room, in a textile shop, etc. We are getting multiple images. So for this example we can see that we are getting the object is placed exactly 2 cm from the first mirror and 1 cm from the second mirror. The total of 1 plus 2 is equal to 3. Fine. So the image produced by this one will be, take it as exactly the same number, that means 2 cm and 1 cm, and this will be the first images of both first mirror and the second mirror. The next image produced, it will be this 2 plus 3, it's exactly 5 cm, that is found here. The next one, so this one I take it as mirror number 1 and mirror number 2. And here we can say that 1 plus 3 we are getting a 4 cm, that exactly here. And 4 plus 3, 7 cm, it's exactly here, the third image. 5 plus 3, 8 cm, we are getting the next image, and it goes on up to infinite. If you are placing two mirrors parallel to each other, we are getting infinite number of images, and this is how to find out the distances of these images. Let us consider if the two plane mirrors are placed like this, and this one is the mirror number 1 and this one is the mirror number 2, and I place an object exactly here 1 meter from the mirror number 1 and 1 meter from the mirror number 2. So in this case, how many images will be produced? Let's see. So what happens to the images produced by these two mirrors? So first of all, the first image produced by the first mirror, it will be exactly 1 meter here, and this will be expanded like this. So this is exactly at 1 meter. It goes like this. Fine. So this ray will not meet any mirror other than this one. So there is no image will produce due to this mirror, this ray. The same manner for this thing, the image produced is exactly 1 meter from here. That means here will be the image produced, and this ray is also extended. It goes like this. So for this case, we are getting two images by using two mirrors are in parallel. These two are in parallel, but we are placed like this, so that is why we are getting two images by these two mirrors. Suppose they are asking about how many images can seen by an observer. For all the cases, observer can see only one image. So this is very important. For both the cases, our question is how many images produced. So for finding out how many images, we need to draw the ray diagram and find out the answer. If the question is how many images can be an observer can see, the answer is one image. I hope you understood these two concepts. Now consider if we place two mirrors perpendicular to each other. If two mirrors are placed exactly perpendicular to each other, what happens when I placed an object exactly here? That means symmetry. The distance between these two is, I consider it as A. So I'm naming it as, this is my first mirror and this one is my second mirror. Fine. So according to this diagram, the image formed by the first mirror for this particular object is exactly formed such here. Yes. So the distance between these two is A. So one ray is going like this and no problem, it will goes like this. No problem. Another ray which is going through this, going to hit here. Yes. So this ray produces an image because this is the object for this second mirror, and the distance between these two is, what is the distance? The distance between these two is A. This is also A. If this one is A and is exactly produce the image as, the distance between these two is A, and this image is the object for this second mirror and is produced exactly here. We are getting the image number 2. This is image number 1. Fine. Let's move on to the next mirror. Find out on this case what happened. Here we are getting an image here, right? And this is our image number 3. For this case, two rays are going on, no problem, it goes like this. And here one ray is coming and it's going to be hits here. And this third image is the object for this first mirror, so that we are getting an image, distance it as A is the distance here, and exactly the same distance like here. So this is A, and we are getting another image here. So we are getting another image as image number 4. So image number 2 and 4 are equal at the distances. So we are getting 3 images if we place 2 mirrors perpendicular to each other. Perpendicular to each other. And the object is at the bisect. So here you have the object. So bisects place exactly at the bisects. So according to this one, this image is produced because of one reflection. This image is produced because of one reflection, but this image is produced because of 2 reflections. The reflections from the mirror 1 and mirror 2. So we are getting 3 images on this case.
So I hope you people enjoy this video. See you soon. Bye, Sanjeev.